Hi students, welcome back to the online classes. This is the third session of the chapter playing with magnets. So, in the previous session we are discussing about the magnetic nature of the magnetic property of the earth. So, let us start the session with the same topic. So, I have considered a magnet and I was freely suspended this magnet. If you suspend the magnet freely through a thread, here the red region, the red colored part of the bar magnet represents north pole and the blue colored region represents south pole. If you suspend it freely, the north pole, that is red colored part of the magnet, will always point towards north direction, and the south pole, the blue colored part, will always pointing out towards south. So, for my position, this is the east direction. How we will know the direction of the east? We will know the direction of the east, where the sun rises is the east. So, from here, from this side the sun is rising. So, that is why this is the east direction, and opposite direction to the east is west. So, to know the directions of north and south, stand facing towards east direction, then your left hand side represents north and then your right hand side represents south. So, for my position it is north, so it is south, east, west. So, north, south. So, I have considered a bar magnet and I was suspended it using a thread. So, how the red colored region is showing? The red colored region is pointing towards in the north direction. So, the north pole will always points towards geographic north. We will call these as geographic directions. These are geographic directions. So, according to geographic directions, so this side is north. So, that is why if you suspend, so why the bar magnet aligns like this? So, if you suspend bar magnet, it arranges in the direction of north south direction. What is the reason behind that? So, to know that, I have considered another bar magnet. Let us place this bar magnet under this bar magnet, under the suspended magnet. So, if you observe here, the north pole of the suspended bar magnet is towards the south pole, placed below the suspended bar magnet. So, if I rotate the magnet, so what is happening? The suspended bar magnet is also rotating. Did you observing that? I will again rotate it. See. So, what has happened? Again the suspended bar magnet is rotated again. So, again rotate. So, what was happening here? The suspended bar magnet, the north pole of the suspended bar magnet is always towards south. So, here the earth acts as here we are performing the experiment on the earth. Earth will act as a big bar magnet. The nature of earth is a big magnet and it acts as a bar magnet. Earth is a very big magnet and it acts as a bar magnet. So, the suspended magnet, the north pole of the suspended magnet is always towards geographic north. Why? Because inside the earth there is a bar magnet. Assume that inside the earth there is a bar magnet, and the magnetic south pole, earth's magnetic south pole is towards geographic north. Earth's magnetic south pole is towards geographic north. Earth's magnetic north pole is towards geographic south. So, what is the direction of north? This is the geographic north, and magnetic south pole is towards in this direction. That is why this magnetic north pole is attracted to the Earth's magnetic south pole. Earth behaves as a magnet. If you are suspending the magnet, why it is pointing towards in this direction? Earth's magnetic south pole is in this direction. That is why this north pole is attracting towards the this north pole is attracting towards the Earth's south pole. Where the Earth's south pole is, Earth's magnetic south pole is towards geographic north. Geographic north. So these are the geometric directions, geographic directions I have represented here, and so this is the north, south, east, west, east, west, south, north. So towards geographic north, magnetic south pole will be there. Earth's magnetic south pole will be towards geographic north direction. Earth's magnetic north pole is towards geographic south. So where the Earth's magnetic south pole is located? Earth's magnetic south pole is located near to the Earth's magnetic south pole is near to geometric north pole. Earth's magnetic north pole is near to geometric south pole. So if you consider a bar magnet, you have considered a bar magnet, it is having two poles, north pole and south pole. If you place the nail here, it will not be attracted. This magnet cannot able to attract this nail. So it cannot apply force to this much of distance. So why? Because there are some invisible lines around this magnet. You cannot observe those lines with your naked eyes. So there are some lines presented around this magnet. If you place any magnetic substance which is in contact with these lines, then it will be attracted. If you are placing a magnetic substance at this position, here this object is not in contact with magnetic lines. Hence this object cannot be attracted by the magnet. But here you have placed a nail here, this is attracted by the magnet. Why? Because this nail is in contact with the invisible lines presented around the magnet. Have you found any invisible lines around it? Yes, they are presented, but you cannot able to observe those. So they are the invisible lines that will present around the magnet. So we will call these lines as magnetic lines. We will call these lines as magnetic lines. Magnetic lines are from, magnetic lines is having some direction, and this direction is from north pole to south pole. You have to represent an arrow mark, north pole to south pole, north pole to south pole. So this is the direction of, I was representing with an arrow. These are the magnetic lines presented around the bar magnet, and its direction is from north pole to south pole, north pole to south pole. So similarly, Earth behaves as a bar magnet. Earth is a very, very large magnet, and its behavior is similar to a bar magnet. So there are magnetic lines presented around the Earth. Magnetic lines will present around the Earth. So since geometric north is towards, magnetic north is towards geometric south, and magnetic south is towards geographic north. So magnetic lines will be starts from north pole to south pole. The direction of the magnetic lines is from north pole to south pole. You have to represent with arrows. You have to denote, whenever you are drawing the magnetic lines, definitely you have to represent the direction. The direction is from north pole to south pole. So the Earth is surrounded by the magnetic lines. So let us learn about another one. So for example, if I was given an object to you and I asked that whether the object is a magnet or not, whether the magnet is I have given two objects for you. Let us say I have given three objects for you which is in the shape of a bar magnet. So I have given three objects. These three objects are in the shape of a bar magnets. So these substances don't have any colors. There is no denotation, it doesn't have any signs about the poles. These three objects are looking same, but these three objects doesn't have any blue and red colors in order to distinguish the poles. So these are the similar objects I have given for you, and what I asked is, among these three objects, which object is a magnet? I have given three objects for you. Among these three, which is the magnet. I was asked to find out the magnet from this, to find out the magnet from this. To find out the magnet among these three objects, you need some other magnet. I have considered a magnet. So I was placed this magnet near to this object. So this object doesn't attracted by this magnet. It is neither attracted nor repelled. So this is a non-magnetic substance. If it is a magnetic substance, it will be attracted by this magnet. If it is a magnet, it will be either attracted or repelled by this magnet. It is neither attracted nor repelled. So it is a non-magnetic substance. It is a non-magnetic substance. So we know that this is not a magnet at all. So I have given three objects for you, and this object neither attracted by the magnet nor repelled. It is neither attracted, it is not attracted or not repelled by the magnet. So it is not a magnet. It is not a magnet and not a magnetic substance also. And there are two objects remaining there. So let us check about the second object. So I was placed this magnet near to the second object. Yes, the second object was attracted to the magnet. The second object is attracted to the magnet. So I was detached from the magnet, I was separated from the magnet, and I just reversed the bar magnet I had, and again kept near to the second object. What I have observed is after reversing the magnet also it is attracting. So if it is a magnet, from one side it will attract, if you reverse the magnet it will repel. So what will happen? Here if you reverse the magnet also, the object is attracted. In this position the object was attracted. Just I reversed the magnet and again kept near to the second object. Then also this object is attracted. So if it is a magnet, it will show repulsion. It will show attraction and repulsion also. So this is a magnetic substance but not a magnet. This is a magnetic substance. This is a magnetic substance. And let's come to the first object. So I have placed the magnet near to the first object. So the first object was attracted. Then then again I was separated this first object and I reversed the magnet and kept near to the magnet and kept near to the first one. So what happened? When I reversed the magnet, it was repelled. It was repelled. Hence this is a magnet. Hence this is a magnet. So to find out the magnet from the given substance, what you need to know is, if it is a non-magnetic substance, it will neither attract nor repel. If it is a magnetic substance, it will be attracted by the magnet. Of course you have reversed the bar magnet, it will be only attracts to the magnet. But if it is a magnet, definitely it will show the property of repulsion. Definitely it shows the property of repulsion, and hence we can say that repulsion is the sure test for magnetism. Repulsion is the sure test for magnetism. To identify the magnet, what is the sure test? The sure test is the repulsion. If the object repels another magnet, definitely that object is a magnet. Definitely that object is a magnet. So what is the sure test for magnetism? Repulsion is the sure test for the magnetism. So let us know how we can make our own magnet. How can we make our own magnet? How can you make your own magnet? So making own magnet. So let us consider a nail. Let us consider a magnetic substance. So generally we will easily get the nail. We can find it at our homes. So, I have considered a nail. A nail is a magnetic substance. So, consider a nail and consider a bar magnet also. Consider a nail and consider a bar magnet also. So, keep one end of the bar magnet in contact with one end of the nail. So, keep the bar magnet in contact at one end of the nail. Keep this bar magnet in contact at one end of the nail. So, what is the process of making our own magnet? Consider a nail and a bar magnet. Consider a nail and a bar magnet. Place the bar magnet in contact. Place the bar magnet in contact at one end of the nail. At one end of the nail. So, you have considered a nail and you have kept the bar magnet in contact at one end of the nail. So, slide this bar magnet along the length of the nail. Slide this bar magnet along the length of the nail until it reaches to the other end. You have to slide the bar magnet until the magnet reaches to the other end of the nail. So, you have placed the bar magnet in contact with the nail. This is north pole, south pole. You have to slide this in this direction. You have to slide in this direction until you reach other end of the nail. So, slide the bar magnet along the length of the nail, until you reach. You have to slide the bar magnet until you reach other end. So, at the other end, lift the bar magnet. At the other end, you have to slide the bar magnet along its length and lift at the other end and bring it to the starting position of the nail. So, lift the bar magnet at the other end. Lift the bar magnet at the other end and bring it to starting position. So, initially you have placed the bar magnet here and you are you slide the bar magnet until you reach the other end. So, lift the bar magnet here, again place it in the starting position. So, again slide the bar magnet along the length of the nail and again place at the starting position. So, repeat this process for 20 to 30 times. Then this nail can be converted into, you have to lift here. You have to lift at the other end of the nail and again you have to reach to the first initial position. So, repeat this process for 20 to 30 times. Then this nail will be converted into the magnet. Then this nail will be converted into magnet. This nail becomes magnets. So, if you have any iron substances which are in the shape of a bar, then if you do the same process for that iron bar, then it will be converted into a bar magnet. So, what you have to do? You have to rub the magnet in one direction. If you rub like in irregular directions, then it will not becomes magnet. You have to take the magnet and rub the magnetic substance in one particular direction only. Then this magnetic substance will becomes a magnet. So, lift the bar magnet at the other end and bring it to starting position. Then slide again. So, repeat this for 20 to 30 times. repeat this for 20 to 30 times. Then the nail becomes, then the nail becomes a magnet. Then the nail becomes a magnet. Then the nail behaves as a magnet. So now let us learn about another concept, that is magnetic induction. Magnetic induction. So, to know about the magnetic induction, consider a nail, again consider a nail and a safety pin. So, I have considered a nail and a safety pin. Does this nail attracts the safety pin? No, it will not attract the safety pin. This nail doesn't attract the safety pin. So, if you bring this nail in contact with the bar magnet and now try to attach this safety pin to the nail. So, now the nail is attracting the safety pin. So, initially this nail doesn't attract the safety pin. Initially this nail doesn't attract the safety pin. So, if a bar magnet is placed closer to the nail, then it is able to attract safety pin. What was happened here? This nail behaves as a magnet. This nail acquires magnetic property. What is magnetic property? Attracting the magnetic substances. So, initially this nail doesn't attract the safety pin. When the magnet is brought near to this nail is attracting the magnetic substances. So, here this nail is achieved, this nail is acquired magnetic property. So, when a magnet is placed closer to the magnetic substance, so this magnetic substance, here it is, we have considered nail. So, this nail is able to attract the safety pin now. So, initially this nail doesn't attract this safety pin. Initially this nail doesn't have any magnetic property. Later, because of the presence of bar magnet, this nail acquired magnetic property. So, magnetic properties are created in this nail because of the presence of bar magnet close to it. When you place bar magnet close to the nail, magnetic property is created, magnetic property is produced. So, in the place of produced or creation, we will use induction. What is the meaning of induction? Created or produced. Magnetic properties are produced in the magnetic substance due to the presence of magnet. Magnetic substance acquired magnetic property. That's why it is able to attract the safety pin. So, what is magnetic induction? Magnetic substance acquires magnetic property due to the presence of magnet is called magnetic induction. So, here the magnetic substance nail acquires magnetic property. Why this nail is acquired magnetic property? Due to the presence of bar magnet, is called. So, that magnetic property produced in this nail, that process, that phenomenon is called as magnetic induction. So, this is the last final topic from this lesson. So, in this lesson we have learned what we have learned. So, we have learned what is magnet. What is the magnet? magnet is a stone which attracts some substance. It does not attract every substance, only few substance will be attracted to the magnets. So, magnet is simply a stone which attracts some substances. Who discovered the magnet first? Magnet is discovered by a shepherd and his name is Magnus. His name is Magnus. So, he discovered a stone, he discovered a stone, we will call that as magnet. So, what is the natural stone he was firstly discovered? He was discovered a natural magnet, we will call that magnet as lodestone. What is the natural magnet available in nature? Lodestone. So, initially Magnus, the person Magnus has found a stone called as lodestone. Lodestone is a natural magnet that is available in our nature. So, what we have learnt after that? We have already learnt about magnetic materials. The materials which are attracted by magnets are called magnetic materials, and materials which are not attracted by the magnets are called non-magnetic materials. And what are the poles of the bar magnet? What are the poles of a magnet? Poles of a magnet. What is meant by poles of a magnet? So, every magnet is having, especially bar magnet is having two ends. When compared with its body, at the ends it is having high attracting capacity. We will call those ends as poles of a magnet. What are the two poles of a magnet available? So, north pole and south pole. And what we have learned next? We have learned about directional property. Directional property. What is meant by directional property? When a magnet is suspended freely, it aligns, it arranges in the direction of north-south. So, this property is called as directional property. So, what is the device that works on the principle of directional property? Magnetic compass. Magnetic compass works depending on the property of directional property of magnet. And we have seen how can we make our own magnet. How can we make our own magnet? We have to rub the substance, magnetic substance in single direction. Then the magnetic substance will become a magnet. It will behave as a magnet. And later finally we have learnt about magnetic induction. Induction means produced, created. Magnetic properties are created in the magnetic substance. Magnetic substance acquires magnetic property due to the presence of magnet. So, this process is called magnetic induction. So, with this lesson playing with magnets is completed. Thank you.